Hello guys, hello, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying a lot. We are enjoying a lot and we are just learning every day. Hope the same for you guys. So yeah, till the last session we have looked into we have jumped into the new field. Like I will say a new module that we are having. Okay, right? Machine learning. Okay, so yeah, before that we have completed everything which is related to data, like working with data, performing EDA, visualization, everything related to data. Now we have jumped into a new thing in the data science itself. So that is YAML, that is machine learning. So we have introduced you what is ML and the types of machine learning, and then we have introduced you what is supervised learning. Inside which we have looked into the types, like we are having regression, classification, and in regression we have looked into the theoretical concept of linear regression. Okay, hope you guys have a proper understanding. If you guys doesn't have a proper understanding, please make sure that you guys have watched all the previous session videos so that you guys can have a better understanding of what we are telling. Guys, today is a coding session. Okay, so I think for the past two sessions we have the theoretical understanding of what is linear regression, right? So what is linear regression? I will just recap you for a gist of a thing. Like linear regression is comes under the regression problem. It is one of the supervised learning algorithm. So whenever it is linear regression, right, you guys need to know, you guys need to have an understanding of y is equal to mx plus c. That's it. Y is the output variable, that is dependent variable. X is the input variable, that is the feature or independent variable. We are having m, that is the slope, and c is the intercept. That's it guys. Okay, y is equal to mx plus c. So if it is linear regression, you guys need to know this is a formula. Okay, yeah, today we're gonna see the coding part of linear regression, guys. Okay, I'm very much excited. Now you guys gonna see the real time use case of what how this linear regression will work. Okay, so without wasting any time, let us jump into the session. It's not gonna take more time. Okay, yeah. So what is the first thing? So in order to this is a collab. Okay, before going for the coding part, this is my way. Like this is collab. First of all, you need to know what is the IDE that I'm using. So if you guys doesn't know about this IDE, we have a dedicated session. We have done a dedicated session while we have explored the basics of Python. So make sure that you guys watched all the sessions. So that's the reason we are just asking watch the session so that you can have a better understanding of what is collab, how to set it up, how to just open the collab, like those things you can able to understand. Okay, so that's a way. So I'm just using collab. There are different IDs available, but collab, I hope, like most of the time I will be using this. It's very user friendly and it makes the things very easier for sharing everything. Okay, so yeah, without wasting any time, now let us discuss this. Okay, linear regression, first of all, not to use anything, I'm just gonna import some necessary libraries. Okay, I hope like you guys know about NumPy, right? It is gonna perform all kind of numeric operation, addition, subtraction, multiplication, average, and some complex operations like all logarithmic, like those things. Okay, that is why we are using this NumPy. Okay, next pandas. Okay, pandas as PD. So this as NP is the alias name. Okay, you doesn't need to put NumPy each and every line of your code. Rather than you can use NP. Okay, so then we are having pandas, right? Pandas is used to treat the data set in a form of a table. I will say it is a data frame. Okay, we will call it as a data frame in the data science. Then we are using matplotlib.pyplot.splt. You guys know about it. For visualization, we are using that. SKLearn and model selection tried test split. So this is a major thing. So I hope like you guys know about what is training and what is testing data. Okay, so we need to, whenever we have a data, we need to split them into training and testing. For that, we are using a package called as train test split from sklearn dot model selection. And guys, see here, this is how I just load the linear regression model from the sklearn. Sklearn dot linear model from class import linear regression. That's it. Okay, now how to evaluate it? We are having sklearn metrics, that is mean square error or f2 score. Okay, that's it. So hope you guys have a clear understanding of what these statements doing, right? So this is the first step. Whenever you were just coming for a coding, you guys need to have, yeah, these are the first step. That is a necessary step that you guys need to follow. Okay, so guys, till this point, if you guys feel any difficulties, please make sure that you guys just express to us or like in the comment section so that we can help you. Okay, So this is how we can import your necessary libraries. Moving on, we're going to load our dataset. Okay. So here I'm just creating my own dataset by using an NumPy library. Like you guys can see here, I'm just setting the seed 0 so that if I'm sharing this notebook to anyone, right, everyone will have the same output. Otherwise, whenever you just run this random function, right, it's gonna generate the random values. Okay. Let's see how I am just creating the random numbers. So guys, for x, I'm just creating random of rand, that is from the value of 100 in a count of 1, I'm going to create a x value. Okay, that is what my x. I'm just multiplying by 2. And what is my y? Similarly, I'm going to create the random value of 100 with deviation of 1. And I'm just including this x here also and multiplying the term with 3 and creating or adding it up with the 4. So I'm just creating a random numbers. Okay, x I'm just creating, and then for the equivalent x I'm just creating a y, and I'm just giving to the data frame. Okay, like pd dot data frame. My data is np dot h stack. H stack means horizontal stack. It will stack like this. Okay, vertical means this type. So horizontal stack means this. We are having x and we are having y. So that's why we are giving like this, and we are creating a table kind. That's it. That's why I'm just passing it to the data frame. Now this dataset has a table format of x and y, and I'm just giving to the features and target. So this is my feature and this is my target. Guys, just look into it. This is the dataset that we gonna play. Feature is our input and this is our output, and we will be having nearly 100 records because we are just specifying x and y should be 100 counts. Okay, so I hope like till this point everything clear, right guys? So what we have done, we have just installed the necessary libraries and we have imported the dataset, that is we have created the dataset and we have displayed it. Okay, so what the next step we are having, we're gonna summarize the dataset. Okay, that is dataset dot summary. Guys, this is a statistical summary, guys. Okay, believe or not, like it gonna take more time rather than just calling this describe function. Okay, how simple the Python, guys. Okay, dataset dot describe, what it does means count of each features. Yeah, there is no null values, right? Because we are having 100 codes, exact 100 codes. Next, what does that mean? It is 0.94, whereas for the target is 7.0. What is the standard deviation? What is the minimum value that we are having? 25%, 50%, 75%. What is the max value we are having? Like that, it just gives the statistical summary about the each and every columns present in the dataset by using the describe function. Next, once it is done, we are just going for the pre-processing step where we're gonna check whether the dataset is having any like need any pre-processing, because like in the summary itself we can see, right, it has all the 100 records. Okay, but we are just checking from our side. That is how we can check, means how we can check the missing value. Dataset, it's a dataset name which we have loaded our dataset to a variable. Okay, is null is a function that tells whether like this data set, this data frame has some null values. Dot sum, it will show for each column how many null values are there. Guys, see here, we are having feature column and target column, right? Feature column, there is only 0 null values. Similarly for the target column, there is d0 0 null values. And one more thing, guys, the data type is int. So, okay, so in order to make the model to digest or train, the value should be in a number form. So integer is a number, so the machine can understand, that is we can directly go into. So till this point, guys, we have just installed and imported the necessary libraries, loaded the dataset, that is created a dataset, then we have summarized it, and we were went for the pre-processing step. Hope guys, we have done 4 different things. Hope you guys are enjoying a lot. Okay, so today we are just giving a live what it is happening. Okay, so yeah, we will just have these things. Okay, so yeah sir, over to you.
Yes. So, guys, here we will be applying the knowledge. So, if you have come to this session, so go and watch all the previous sessions 5 to 10 times and understand all the concepts and application. So, absorb the information, digest, and apply the information and concepts. So, write in the comment section what have you learned, what is your long-term objective function, and also subscribe to our channels and press the bell icon so that you will get notification, and give us feedback on how much improvement you want and what are the improvement areas, and if any suggestions will be incorporated if they are simple and realistic. So we'll be doing that. So let us go to this particular application, supervised learning. Here we will be applying, we are applying the linear regression. Okay, so first of all, Google Colab. Google Colab is it's IDE, and it is a Google research laboratory. Like it's a uh, so it is online ID, which is like you can use it. You don't have to use your computer computation, and you can buy GPUs or CPUs or whatever space or as per your project. So you can use it on the go with R, Python, and SQL. You can use all of these tools on this. So it's very simple. So we have already shared, already discussed how you can install it and connect with the data, and how you can store data, and it depends on where is your data, and you can connect with the data, and then you can perform the functions and libraries. Okay, so linear regression is like we'll be importing necessary libraries like NumPy, import NumPy, Pandas, Matplotlib, okay, sklearn. So we'll use linear regression model, import linear regression like from sklearn, and metrics we can yeah, we can use different metrics and all. So loading, we'll load the data, and then gathering the sent data we'll use np, which is numpy.random.seed bracket 0, and different functions. Here we'll be loading it x and y variables on random np.random.rand. So we have from 1 to 0, 1 to 100, we have taken the range, okay, and in x variable. On y we have taken again 100 to 1. With in x we have taken the features, and in y we have taken labels with noise. Okay, so data set, again we have used pd.dataframe. Okay, and x and y variables. Features are, column is features and target. So data set, you can see features and target, which is from 0 to 99, because yeah, 0 to 99, and they are complete 100 rows and 2 columns. So this is how the data set will look like. Then we have a summary of the data. Summary of the data, we'll see what is the summary. So based on features and target. So mean, we can see count from 100, feature 100 and target 100. Mean is 94 and target 7.02. Okay, so then we have standard deviation, min, and we have like from 25% we have 0.41 and 5.48 at target, and then we have 50% at 0.93 and 7.24 at target, and 75% at 1.36, and then we have 8.5 at target, and max is 1.9, and target is 11.75. So this is the summary of the data set for features and target. So then we do pre-processing, guys. Pre-processing on data, we'll check the missing value, because see, whenever we get the data we collect, we have to do all these things, because we'll have a feel, we'll check the behavior.
It's not so true.
We'll check the behavior, and we'll check other aspects of the data, so that we can do end-to-end pre-processing, and other cleaning and processing methods we can apply. So then we have pre-processing the data, checking the missing value. We'll check the missing value. So feature 0, target 0, data type is integer 64. So this is how we check missing value. Then we go to um, segregating the data set into input and output. Okay, and then we'll based on features and target. Okay, target value, feature value, and then we'll see the array. So this is the array which we have, where we have segregated input and output, guys. So this is the outcome of that. And let's go down. Yes, so you can see that, and we can see, so we have to see also shape of the data, which is X and Y shape. So that is 100 and 100. Okay. And then we can do splitting of data into training and test data. Okay. Yeah. So let's start. Over to you, Raja.
Yeah, sure, sir. Yeah. So, guys, we have discussed till pre-processing, right? So we have just looked into there is no missing values, and now the model can understand it, right? So because like it is an integer. Now we need to make the data set input and output split. Okay, we know first column is input and the second column is output. That is the feature is the input which belongs to X. That's it. From the data set, I'm just having the feature and I'm converting it to a value. I'm just giving it to the value variable called as X. That is our input. And Y, which is our target value, right? So that is a target from the data set that is belongs to the Y. That's it. Guys, see here we are having X. Okay, that is our input, and we are having our Y, that is our output. Okay, now as I'm printing the shape, it is simple, right? Because we have created 100 records, both X and Y as the 100 records. Okay, now so next step is to split the dataset into training and testing. That is, we need to train from this 100 data, we need to train with the 80%, and we're going to test it with the 20%. So that's the reason I'm just using train test split. What is my input? X is my input. What is my output? Y is my output. What is the test size? 0.2. That's mean 20% for testing. And random state is 42. So as I explained previously, random seed dot zero means it gonna whenever you run the cell, you're gonna get the same value. Similarly, random state 42 will have the same experience. Like it gonna split the train test part same for everyone who are using this collab notebook. Okay, so that's it, and we're gonna have our training and testing data. So here you can see, guys, X train, X test, Y train, Y test. So what is for testing we are having? You guys see here 20 data. This is X test and this is Y test, 20 data. But training we are having 80 data. But totally we are having 100 data, 80 data for training, and 20 data for testing. That's it. That's how we are using this function called as train test split. Okay. Hope it is easier. Now, now I'm gonna load the model. Simple, just linear regression because we have already imported it from sklearn. Sklearn from sklearn.linear model. I'm just imported this linear regression. That's it. Okay. So now this model has linear regression, right? Now, how to train it? Model.fit. Fit is a function which is used to train the model. Okay. Simple. Okay. What is my input? X train. What is my output? Y train. X and Y are our input and output, but I'm just giving the training data only because fit is used to train the model. I'm giving only training data. Okay, that is 80 data. Now it is trained. How to predict the result of the trained model? Model.predict. That's it. Okay. For training we use fit. For testing we're gonna use the predict. Model.predict. And what is our input? We just need to give the input because the model has to predict the output. While training, we need to give both the input and output, but for testing, we need to give the output and the model has to generate the result. So, X test is the test data, that is test input data. I'm just giving to the model and it is predicting, and this is what the Y predict, that is model predicted value. See here, this is the 20 values, right? model are predicted based on the experience or training that is it is done for the 80 data that we are having. Okay, now we're gonna calculate our result. Okay, let's see. So how to calculate the result? We are having auto score, right? Auto score y test. What is y test? It is a value present in the data set itself. Now, what is y pred? Y pred is a value which is predicted by our model. That's it. We're gonna pass these two to the auto score, and this is what the auto score. I'm just giving point float value of 2. So because after point it will be the float value, it will only show two values. Okay, you guys can see here the auto score is 0.65. That is 65% of accuracy that we are having for this model. That is linear regression applied to the dataset that we have created. Next, now I'm gonna predict with a single value using the model that I have trained. Guys, till this point, everything clear, right? So what we have done, we have just splitted our dataset into training and testing. Then we have loaded our linear regression model, then trained our model using fit function, and then predicted by using the predict function. Okay. Once we have done everything and we have gone for the metrics, that is auto score, where we have given the value which is present in the dataset and value which our model has predicted, and now we are resulting nearly 65% of accuracy that we have applied for this dataset, the linear regression. Now, how to predict for a single sample? We know, right? For prediction, what we need? Model.predict. That's it. Single sample means you guys see here. What is our input? Okay, these and all our input, right? So you can give any value with points. Okay, so how I can give means consider 1.5 is my input. Since model can understand only array format and we have trained our model in array format, I need to give np.array so that the integer for a float value 1.5 is a float value, right? We gonna convert it to a array. Okay, so that we are using np.array. That's it. Okay, now this is our sample input. I'm gonna pass this sample input to model.predict. That's it. Okay, so sample input model.predict, and the sample prediction will have the predicted value. Okay, so predicted output for the input. Okay, this is input is the input that we have given 1.5, and sample prediction of 0, and we are just restricting it to the float point of 2 because like previously we have done that only, right? So whenever your value is 1.5, the model is predicting it is 8.6 times. Okay, I hope like guys, you guys will be like excited, right? This is a simple code how we can just implement this linear regression. Like now you guys are understand, right? As we are mentioning, there will be only 2 lines of code, guys. Just 2 lines of code. Now you guys can understand, right? So yeah, this is all about linear regression. Okay, yes sir, over to you.
Yeah. So we reached here. So what we will be doing is we have to check the like shape of the data, and you can have we have selected 100, 1 to 100, so you can see any shape. Okay, so we are looking at that much of data, so you can look at different numbers, whatever shape you want to see. And then we are splitting the data into training and test data, because we have to like we have discussed earlier, guys. So we have to train the data, and that would be different data than the test data, because that should be different, because so we'll split data into whatever data we are training. So we'll have different data, and for testing data we'll have, so we'll do x train, x test, y train, y test. So these are the functions for data, guys. Okay, which will be equal to train, test, split, x, y, text, test size 0.2, random state equal to 42. So you can select these numbers based on your parameter, like what training or testing parameters you will have. So it will depend on your thing. Okay, so then we'll go, yeah, then we move, and then we'll do x train shape, and we want to see this train and test shape. So that is 81, 21, 80, and 20. So this is what is the shape. So you can see with these functions, you can see that what is the shape, okay, after you split data sets into training and testing. Okay, then we move to the yeah, loading the model using linear regression. So whatever model you want to use, you can use that. So it depends on your characteristics of the data and the problem statement, objective function, and the characteristics of your data. So which we have already learned in conceptually. So here we are learning how to apply. So we are using linear regression here, model equal to linear regression. So this is how you will use your model. You can use any model as per the characteristics of the data and the objective function you want to achieve. Okay. Then we move to the training the model. We have to train the model because that is very important. So here the magic happens, guys, because training the model, how you're training the model, that determines, and the model, like what kind of model selection you're doing. Like we have you chosen linear regression, it has limitations. And a lot of people say algorithms can solve any problem. It is not true, guys. There are hard problems, like there are problems which right now algorithms cannot solve. Like you have a problem of traveling salesman problem that can't be solved. It is not. And there's a 1 million prize also. So nobody has solved that till now. So there are problems which algorithms cannot. But in future, if we design new algorithms, so will be. So here the magic happens here, guys. It's not, it doesn't matter. What matters is, it doesn't matter that how much knowledge you have and all. What matters is, guys, how well you're training the model and how clean your data is, how much pre-processing you have done, and how well you're training the model. Your model will behave and perform based on this particular aspect. This is very, very crucial. So here we are training on linear regression, and then we've so model is trained, then we go predicting results using the trained model. So we want to see the model predicting X test, we'll see. And you can see because our data type is array, and we have we have done around, yeah. So we have different the different outputs here. You can see what is the average here? We have average accuracy for the
Yeah,
training.
average accuracy. Yeah, 65. Sorry, very rare.
Yeah, okay, sorry. Okay, I got it. So then we see this, and then we are calculating the accuracy of the model, and the average is 65%. You can see below, and yeah, based on that, then we are predicting the output of single sample using the trained model, and then we are predicting that we got 1.5 sample input np.array 1.5 example input, yeah. So then we are getting sample prediction, model predict, sample input, printing f predicted output for the input. So we are getting 8.69 output. So this is for the single sample, okay, using trained model, okay. So this is what for the single set. Okay, let's move down.
Yeah, actually that's it, sir.
Yeah. So guys, this is very simple, right? So this you can only understand when you understand each concept which we have discussed till now. you have gone through 5 to 10 times to all the sessions which we have discussed, deliberated, given examples, done assignments, used use cases, uh, given real life examples, explained again and again so that reinforced learning happens. So then and only you will be able to understand this. That is why it is systematically placed. Like first we need to clear our concepts, then and only we go for application, applying them in a real time on different projects. So this is the project which we are showing you guys so that you can understand the application. So absorb the information, digest the information, and apply, and keep learning deeply with patience and consistency, persistency, and write in the comment section what is your long-term objective function for your career. Keep learning deeply, and we are here to help you. And if you have not subscribed to our channel, subscribe to our channels. Also, press the bell icon so that you will get notification. Keep learning deeply. Thanks.
Yeah, sure, sir. Yeah. So the thing is, guys, as we have discussed, right, it's gonna be only 2 lines of code. So this is what I'm just saying. We are loading the model. We are just you can see, right. I'm just loading the linear regression model. That's it. That's what that's saying. And then I'm just training it by using a single line fit function. I'm just predicting the things by using predict function. That's it. Okay. So for you guys, I just say one more time, what is the flow? We need to install import the necessary libraries. We need to load the dataset. We need to split the dataset into X and Y, that is input and output. Then we need to go for something called as a missing value detection, summary, like those things. And then we need to go for train and test split. We need to load the model. We need to train the model. We need to predict the result. And finally, we need to go for the accuracy calculation. Everything is going to be same, guys. You believe or not, every model is going to be same. Here we just need to change, instead of linear regression, whether it's going to be a multiple linear regression or support vector machine, decision tree, random forest, everything is going to be same. Okay, you guys need to follow just this 10 plus steps to do whatever you guys like. Okay, so I hope like this session is something which is like a eye opening for you guys. Okay, now you guys can understand, right? You guys need to have a proper understanding of what theoretical concept, because like this thing everyone can do. Okay, you guys need to have a proper theoretical concept. So that's the reason we have just doing the theory session first and then the coding session. It's an answer. Okay, so hope you guys are enjoying. Actually, I am enjoyed a lot today. Today is the first coding session of machine learning. It's gonna be like this, guys. We're gonna learn the theory concept and we're gonna dive to the code. Theory code, like that we're gonna do. So yeah, I'm very much excited to do the upcoming session. So yeah, this is what about today's session. Hope you guys have enjoyed. If you guys have any doubt, just don't hesitate to ask to us. Please post it in the comments. We will take up and we will solve your doubts. Thank you guys. Thank you so much for all your time. And yeah, if you guys doesn't subscribe to our channel, please subscribe to our channel, because like it's gonna be a year-long program, and we will be posting the video every day, guys. Okay. So yeah, that's it from my side. Thank you guys. Thank you so much. We will all meet in the next session. So until then, guys, bye. Take care.
Yeah, thank you, everybody. We are enjoying each bit, each detail of this particular program. Keep learning deeply, absorb the information, digest the information, do the reinforcement. Go watch all the sessions 5 to 10 times. Absorb the information, digest the information, apply the information, and do all the assignments. Keep learning deeply so that you will build lifelong learning mindset and skill set. Keep learning. Thanks a lot.